So make sure this is the review for 220, 230 for Allegheny campus. Make sure you know your basic conversions. Make sure you know your rounding rules. Like I said, I will go through and review some of those rounding rules as we work together. The title of this does say 26 fall 220, 230 review, but it's the same review that I used in the spring. It's the same review I probably used last fall as well. And it should be the same review that you have in your packet. But if there's something different or if there's something missing, please let me know. We will go over and discuss again just some of the helpful equations, reviewing flow rate and drop factor. And then I'll remind you how much I love dimensional analysis and why you should as well. Just kidding. You can use it if you want to, but you don't have to. And these are some additional textbooks if you need them for reference. Sometimes you find the earlier editions, you can find them on Amazon for not too terrible of a price. Okay, so I'm not going to spend a lot of time on these. I'll come back to them if someone has a specific question on these, but I want to get into and talk more specifically about the flow rate and then the new heparin protocol. So please bear with me. I promise we'll get into this here in just a moment. Uh, as a reminder, always remember if it tells you to circle, if it tells you to mark, if it tells you to, whatever it tells you to do, read the directions, please. All right. So, we'll come back to that. That's a good one. All right, hold on, we're getting there. All right. So let's do some of these flow rate questions. I'll do a few of these, and then we'll get into um, the practice questions that you should be familiar with or that you should be exposed to for going into your class or for the heparin protocol. So the first thing is a reminder when we talk about flow rate. So this is what is probably in your review packet. So I'm going to go through this separate example, doing the same kind of criteria that you would need to know for this going through. Go ahead with your question.
Um, will this be posted on YouTube?
Yeah, the review I will record and post on YouTube. Yes.
That will probably be before Monday, right?
It'll be today. Yeah, I'll post it up
Oh,
today. Yeah.
all right. Okay, thank you.
You're welcome. All right. So the this question is a flow rate question. As a reminder, when we're calculating flow rate is volume over time, and the typical flow rate volume over time is milliliters per hour. Okay. Occasionally, they might ask for drops per minute. Okay, which is GTT per minute. And we'll go through, well, you'll know what they're looking for. So, like in this instance, the flow rate they're looking for is drops per minute. And so that's what we're going to solve for. If they ask you to calculate ml per hour, then you calculate ml per hour. So let's take a look and see what we have going on here. So it says your patient has received Solu-Medrol 200 milligrams IV. It's received from the pharmacy in a 250 milliliter bag of dextrose 5% water to infuse over 2.5 hours. The drop factor is 15. There are no other IVs running. What is the drops per minute for flow rate? So when we calculate the drops per minute, I need two pieces of information. I need the flow rate, which is typically an ml per hour, but it could be an ml per minute. I need the drop factor, which will always be given to you, and it'll be drops per milliliter. When you combine those two, and you might, if it's in milliliters per hour, you have to do a conversion, but we want to convert it then to that will make our drop rate, which is drops per minute. So let's look at our data. So the first thing I need is my flow rate. So I need ml, which I have right here, 250 ml. I need a time, 2.5 hours. So that's the first thing. Okay. So I can do a couple of things here. I can take my 250 ml. I could put this over 2.5 hours, which is how I'm going to write it first. And then that's my flow rate. Okay, I'll show you an alternative way where we'll convert this to minutes, but I'm just going to show you kind of like the long version first and show you how to save some time on the second time. All right, so step one, flow rate. Step two is drop factor. What's my drop factor? 15 drops per milliliter. Now, I will say, and so far, right now, the way this is set up, except for hours, we need it to be in minutes. This is all the data that you need from the question above, where a lot of students make a mistake, and maybe you made this mistake in 130, was including the 200 milligrams. For flow rates, we don't care about the strength of the medication. We just care how it's being delivered. Obviously, we care about the strength and the type of medication that the patient's receiving, but for this question, we want to know how quickly are they receiving it. That's the question being asked. All right. So, when I look at what I have so far, I can see that the way this is set up, I can eliminate milliliters. I have drops per hour. Now, if you answer this and leave it as drops per hour, you're going to get some really big number, and that's your clue that it's wrong. Okay. So I need to convert hours to minutes as well. So 1 hour, 60 minutes. Now, I mentioned this in the review session I did earlier today. If you are ever like struggling, like, and you accidentally multiply when you should divide, or you divide when you should multiply, a lot of times it's because you're putting the number first, followed by the unit. You should always put the unit first, and then what number goes with that unit, right? So if you wrote 60 hours per minute, that should sound really weird to you. But if you say 60 minutes per hour, then you know the 60 goes with minutes, the one goes with the hour, and it makes things make sense. All right, so the way this is set up, I'm just going to plug it into my calculator, and then I'll show you the what I would consider the easier way. So I'm going to take 250 times 15 divided by 2.5 divided by 60. And with all those big numbers, I get a final answer of 25 drops per minute. I know I'm in drops per minute before I even do my calculation because I eliminated all the other units. This is the beauty of dimensional analysis. Now, if you've had review sessions with me before where we've talked about these flow rate questions, you know that I'll mention the alternative way is instead of doing this extra step, because sometimes you already hate dimensional analysis, now I'm asking you to do an extra step. One way we can kind of circumvent that is just take that 2.5 hours, um, multiply it by the 60 minutes. So you're converting hours to minutes. So 2.5 times 60, and you're going to get 150 minutes. What this does is it saves us a conversion factor. So I'm already in minutes, and then I just have to multiply by my drop factor. So we cross those out. I'm left with drops per minute, and then I get the same answer, 25 drops per minute. I just wanted to show you that there's two ways to kind of go about answering that question, just so you know. All right. Some of these other ones are pretty straightforward. I'll come back to them if we need to, but when you're doing just basic flow rate, it's just volume over time. So 120 over 90, convert the minutes to hours. For this one, 375 ml over 3 hours, just 375 divided by 3. So your answer is 125 mil per hour. Nothing that should be unusual. Now, where things start to get a little bit more nuanced is they're going to ask you to do a flow rate conversion. What do I mean by that? They're going to ask you, like in this question number 20, they're going to ask you to convert 8,000 units per hour to milliliters per hour. So knowing how to do this will help you out, especially when we get to the heparin question. That's looks more daunting than it actually is, once I explain a little bit about it. So there's a couple things. So first of all, this tells us that we have 0.45% normal saline, 500 milliliters IV with heparin, 20,000 units to infuse at 8,000 units per hour. But we want to know what is that flow rate in milliliters per hour. And this is something you're going to have to do in the heparin protocol. What's important to note is that your IV contains both these things. This is one thing. This is your available, for lack of a better term. Okay. So this is your available, meaning another way that we could write this is I could say it's 500 milliliters per 20,000 units. Or I could say 20,000 units per 500 ml. It really doesn't matter. Just know that they go together. Okay. That's going to be really, really important. Now, there's a couple of different ways to set up this problem. Some people will start with mLs, which is a good way to start. Some people, including myself, will start with the starting flow rate and then move to the converting rate. It's really up to you what you decide to do. So I'll show you both ways on this problem, and then we'll work through one more like with an insulin, and then we'll get into the heparin protocol. So the way that my preference when I'm setting this up, I like to take my starting flow rate, which is 8,000 units per hour. And what I want to do is I want to set up a conversion that'll help me get to ml per hour. So I already have my hour where I want it, but I have units here and I don't want units. What do I want? Well, what I want goes here. I want milliliters. And I want to know, can I convert milliliters from a given units? And I can. That's why I made a point to tell you like this is your available. Okay. So what I'm going to do is I'm going to match the numbers with the units. Remember I said that earlier? So I'm going to take my 500 milliliters and my 20,000 units. And what I end up doing is I'm eliminating units and I'm left with what I'm looking for, which is ml per hour. The alternative way of doing this, and I'll work out the math in just a second. I just want you to see that it's basically the same thing. The alternative way to look at this is some people were taught, and I was also taught this by some of my teachers over the years, is start it. We always called it start with the end in mind. So what am I trying to end with? Well, I'm trying to end with milliliters. Okay. So I start with that. I want milliliters. But what goes with that milliliters? You have to remember to keep the units with it. If you just kind of put that wherever, you're going to get weird answers. Then you want to convert and get rid of the units. So again, I'm going to write units up here. And what's my only other thing that I have that has units in it? It's the units per hour. So 1 hour, 20,000 units. So, oh, I'm sorry, 8,000 units. Oops. Let me erase that. Someone will come at me in the YouTube comments and be like, "Why'd you write 20,000 units?" And I was like, "Did you not listen to this?" Okay. So, units is gone. What am I left with? ml per hour. So, sometimes people ask me like, which way is the right way to do this, or I do it this way. Well, A times B equals B times A. It doesn't matter the order as long as it's arranged appropriately. What's more important is the up and down or the numerator denominator. Make sure those things are right and make sure before you do any math, especially when you're doing these, make sure the units make sense. Make sure the conversion units make sense. So, if I take 8,000 times 500 or 500 times 8,000, and then I divide that by the 20,000, I get a nice even, no matter which way we do it, 200 milliliters per hour. Go ahead, Alexis.
So I do have a question. So the numbers that are using in this, are they different from what the study guide we got? Because that's a different number, numbers for 20 on here.
It might be, yeah, it might be. I have created like I changed some of the numbers to create a little bit more variety. But the setup would still be the same.
Okay.
What numbers do you have on your sheet?
So like your 20 doesn't even say that. It's like an order requires 60 milligrams of drug to be administered IM. And that doesn't match with that.
Okay.
Yeah.
So like I said, and that was in your packet.
Yeah, and that email that we got, I guess it was in July or whatever.
Can you add the your packet to the chat so I can download it and take a look at it? Do you know how to do that?
Nope, I don't know how to do that.
Num Number 20 is very similar to what our packet has as like number 22.
Oh, okay. So the numbers are just a little bit off.
Yeah, like like the questions is still the same, the number, the units, the ML is different, and then Alexis is right in terms of like the questioning. Like our the question, some of the questions are a bit different too.
Well, if somebody is able to drop because I don't that they don't send me that packet, and it probably is something that I created a while ago. I've so I don't have it directly the same as you have, but if someone is willing either to email it to me, or drop it into the chat, and then I can pull it up so we can work on the same thing. But I'll put my email in the chat so that way you can message it to me, or like I said, if someone wants to drop it in there, I can take it.
Do you want the whole packet or do you want me to like just clip the
You
uh
you could put the
like
whole
your
packet.
part?
It's
Okay.
okay. I mean, whatever's easiest for you. It doesn't matter to me. So if you give me the whole packet, I can find it. So the other thing is you'll notice that like I have like more than one question per like number. And so I've added extra questions to the reviews. And these questions are on the Google Drive for your reference.
I sent the packet as well.
Okay. Oh, did you email it to me?
Yeah.
Okay, give me 1 second. Let me grab it real quick. It might just be a minute before it opens up. And thank you for doing that. Usually the only packet I get is from 240 that I have that. So, all right, let's open this up and take a look. All right, well, this is definitely one that I created. So let me open this up.
Sorry, I didn't mean to stop you in the middle of everything.
No, you're fine. I appreciate it because sometimes it's helpful that way you're looking at the same things. And so it's always helpful for me so I know what you need help with. Okay, so let's just this here. Give me 1 second here. I'm gonna open this up so I can see it. All right, let me minimize. Sorry for the delay. Give me a couple more minutes here. Just find this. There we go. Okay. All right. So a lot of the questions are the same. I just was obviously going in a different order. Let's just see here. Okay, so I just want to see what your number 20 is. Oh, okay. I hate these questions. Um, okay. So I have been trying my hardest to get rid of questions 20 and 21. But I think they will still show up on your test. So let me just talk about them real quick. Um, just as a reminder, if it's been a little bit since you've seen this, because I think it was on your previous tests. Okay, thank you, Mackenzie. I see your um oh, actually that's better if it's in Word. 'Cause then I can draw on it a little bit easier. Give me 1 second. Sorry, everybody. Okay, there we go. We're almost there, guys. I swear it. Okay. All right. This is the whole packet. That's fine. Okay, good. All right, let me open up my stuff. Thanks for being patient. Okay. And I'm going to go back to what we were doing before just to make sure. All right. So yeah, so for these questions, and just in case, so I don't think none of you were necessarily asking me about um, the um, these questions just yet, but if it's been been a minute since you've, oh, of course, I apologize. There we go. I hit the wrong button when I was trying to write on it. Thought this guy knew what he was doing. All right. Here we go. Okay. We're back. All right. Yeah. So, yeah, for these questions, like I said, I'm not a big fan of these questions just because I think we've asked better questions, but it might still be on your test. So if you do see these on your test, just remember it'll always say, it'll tell you something like use the strongest concentration. So you need to know that 20 is your strongest concentration. Sometimes on the test, they'll rearrange the order. So instead of 5, 10, 20, it might say 15, 10, 5. So just pay attention to the order. And then when you are doing your calculation, this is where you could just do your ordered over available times your 1 mil. And then your answer for this would just be the 3 mil. Hopefully you've seen this one already. Like you should have seen it last semester with 130. Same thing with this question. Um, this is an example of a oh man, I'm just having a blank. But this is a question where basically the label tells you how much liquid to add to get to the solution that you're looking for. So you actually can ignore this section in case it's if you haven't heard me say that before, or if I skipped over this and didn't do this. But what you care about is the units per ml solution, and then again it tells you to choose the strongest. So the strongest is always going to be the highest number, and then you just do your calculation. Now, there is something important about this question because when you take your 350,000 units and you divide by your available, which is the 1 million units times your 1 ml, you get an answer of 0.35 ml. You're going to be tempted to round that to 0.4. Please don't round it. That's your answer. Remember, numbers that are less than, so if we have a number less than 1 milliliter, then you're going to round to the 100th place, meaning like 0.25, you would, and it's usually mLs, that would be the answer. Here it's 0.35. If you get an answer that's 0.5, then that's your answer. You don't need to do anything else with that. If you got an answer that was like, let's say it was 0.125, then you would look at the 5 and then decide what you're going to do with the 2. If it's 5 or greater, round up, and so you would put your final answer 0.13. Okay. Ultimately, in all reality, when we do these like rounding type questions, the real big issue is not so much the rounding as much as what do you have available to you in the form of a syringe. Do you have a syringe that goes to the thousandth place? If so, then then you don't really need to round it. So, all right. Um, so I did a question like this. I'm just going to zoom in a little bit and then make some edits here. So I already did a question with the heparin. I want to do an insulin one and then actually let's just go ahead and do 22, 23, and 24 because I know you want to do 25. I want to do 25 too. So this will go by a little bit quicker. As a reminder, when I'm doing the calculation here, what this question is asking me is how do I go from units per hour to milliliters per hour? So the example I gave you was 8,000 units per hour. This one's only 1,000 units per hour. The other thing is what's in your IV. Your IV is that 25,000 units and 1,000 milliliters. So those two things got to stay together. That's your available. So the way I do this is I'm going to take my 1,000 units per hour, and then I'm going to convert by getting rid of units because I want milliliters, and then I see that I have 1,000 milliliters and 25,000 units. Units cancel out. I'm left with milliliters per hour, and then 1,000 times 1,000 divided by 25,000 gives me a final answer of 40 milliliters per hour. Now that we're on the right page, right document, right questions that you have had access to and practiced hopefully some. Again, you could write this another way. I've had students ask me, can you do this desired over have? You can. Again, I would probably take the 1,000 units per hour divided by the 25,000 units times the 1,000 ml is your quantity. You can do that. You get to the same answer. So whatever looks right to you, as long as you're putting your stuff in the right area, you're doing it right. And I always like to show this from a teaching perspective because I like to be able to show you what we're crossing out. Excuse me, we're going to do the same thing with this. In this instance, we're using insulin. Insulin's infusing at 10 units per hour, and they want us to convert it to milliliters per hour. Again, I'm looking at my IV, 500 milliliters, and then 500 units. Don't get tricked by this U100, right? So this U100 insulin, that's not telling us a value. That's like the 0.9%. It's just telling us like kind of the strength or the concentration of the liquid. So the actual quantity is the 500 units. Now, when you see this, you'll see that everything just kind of cancels out. So again, I'm going to take the 10 units per hour. And if you're setting this up differently and you're getting the same answer, you're doing it right. Trust the process that you're working on. What do I want? I actually want milliliters. And what do I want to get rid of? Units. In this instance, the units and the milliliters are the same, and they're coming from the IV. Okay, because the 500 units of insulin is in the 500 milliliter bag of IV. So the 500s actually cancel out, units cancel out. We're left with ml per hour, and so we get 10 mil per hour. So it ends up being the same. So it won't always be the same, right? Because this was 1,000 units per hour to 40 milliliters per hour. This went from 10 units per hour to 10 milliliters per hour. So just pay attention when you are doing those. But we're going to see this particular question again, number 22, when we get to 25 and here in just a moment. Lastly, this isn't supposed to be like a super difficult like scenario, but sometimes nursing students will make this extra difficult. So all this is asking you to do is to calculate how many hours and minutes basically, that this is going to be infusing for. If it starts at 8 a.m. on a Monday, when will it be done? And so all you're going to do is take your 1,000 milliliters and then, again, I'm just going to do it dimensional analysis wise. I don't want to know the milliliters. I actually want to know the time. So it's 50 milliliters per hour. That ends up being 20 hours that's infusing for. So if we started at 8 a.m., 20 hours later would be what time? So the way I do this, I just say, what would it be 24 hours later? Well, 24 hours later, it will be Tuesday at 8 a.m. And so if it's 20 hours later, we're just going to minus 4. So it'll be Tuesday at 4 a.m. They also might ask you to write it like 0400 because they might want you to do it in military time. So just make sure you indicate like Tuesday at 4 a.m. or 0400. I don't know what specific. I don't even know if they'll ask you this question, to be honest with you, but it's on there just in case. I think you'll definitely get one or two of each of these questions, which is one of the reasons why I added extra questions on the other practice sets. The only thing that I'm missing from my set is this 20 and 21. Maybe I'll try and get rid of that, but you won't have to worry about it for next semester. Okay, let's get into the heparin protocol because I know this is the thing that everyone kind of dislikes. So this is still 25. Okay, anyways. All right, so let's work through this. And let me first introduce this. So I'm going to zoom out just so you can kind of see the whole question and what this looks like. So the I made a mistake when I initially introduced this question. Oh, I don't know, 2012, 15. It's probably been over 10 years now. And the issue is that if you do a Google search, right, or if you do a web search for heparin protocol, what you'll see is a giant box that contains all this information. Okay. And ideally, if I had known a little bit more about how to edit this, I would have put this all together in like a shaded box so you can just see that it's a protocol that you're just kind of following the steps that are required in it. A lot of times students will ask me, do I need to fill out 4? No. Do I need to know the GAIAC stool thing? No. What about neurochecks? No. This is a math test. Okay. So the questions are actually going to be found down here. This is what you're actually answering for question 25. I gave you 4 questions. Okay. A, B is like part 1, part 2, and then C has part 1, part 2, which is again 2 different questions. When you get this question on your test, you're going to get most likely just A and B. You could get C1 and C2, but I don't think that you will. I think you're going to get these 2 questions, meaning you have to get this right and this right to get full credit on this question. The good news is if you miss both of them, you've only missed 1 question. Okay. You haven't missed 2 questions. You've only missed 1. So it'll be written out like, well, you'll have question 25 and then it'll be part A, part B. You just got to answer both of those questions. And I'm going to show you how to do that here in just a moment. Okay. So if you were looking at this for the first time going, what in the world am I looking at here? Just know that you're not alone and I apologize. I gave you some extra practice so you could just kind of prepare or look at how you would read and review the actual protocol. But just know this whole thing is the protocol. In fact, this protocol just repeats a lot of the information that's listed up here, excluding the patient's weight. So if you look at it, it says, I'm going to zoom back in. the protocol tells us to bolus a patient with 80 units of kilogram body weight and then start a drip at 18 units per kilogram per hour. And if you look at step 10 of the protocol, it says that exact same thing. It says bolus with 80 units per kilogram, start a drip at 18 units per kilogram per hour. Okay. So it's just trying to tell you how to navigate this, and then it repeats some of the information. The other thing it says is the patient's weight in pounds. Okay. But hopefully at this point in being third semester, that we don't deal with pounds. We want to convert pounds to kilograms. So you can fill this in, but they're not going to be looking at what you write in this area. Okay. So we do need to know the patient's weight, and we need to know it in pounds. So I'm just going to highlight that. We also need to know what we have available. So what we have available is heparin, 25,000 units in 250 milliliters, half normal saline. If you recall the previous question, like question 22, it had a similar, setup. I think it had slightly different numbers, but it was that 200, or it was some ml with some units of heparin. So that's why I wanted you to see that. That's our IV. We also have a bolus dose available at 1,000 units per milliliter. These are the pieces of information that you need to know from the protocol so you know what to do with the information, because it's not going to ask you to calculate units. It's going to ask you to calculate milliliters. And so we need to know how to convert from units to milliliters, and these availables will help us do that. You don't need to worry about, this just tells you like, and you'll see when we get to C, the part C, that we might have to make some adjustments. I thought it was important that you know how to read the protocol, so that way, if adjustments needed to be made, you would know what to do and how to use that information. So we'll go over that together. Again, step 10 just repeats what was stated at the top of the intro. So you can see, I'm just highlighting all the important stuff so you can kind of see. So if you're going through, if you want to underline or highlight, I'm highlighting what's important. Everything else you don't need to worry about. Okay. Everything else you can ignore. The other thing is, what I'm about to show you is it's a protocol. It's standard. As long as they're doing a weight-based heparin protocol, which that's what you're going to get, your availables are always going to be the same. The only thing that's going to change is the patient's weight. So when you're practicing this, if you want to practice it after we kind of go through it, use your weight, use a friend's weight, use your significant other's weight, make up a weight, like use a different weight when you are doing these conversions. Okay. So what I'm going to do is, before I do anything else, before I even look at the questions, I want to go ahead and answer the first thing, which is, what is the kilograms for a 110-pound person? So if it's been a little while, remember, we're just going to divide by 2.2. 110 divided by 2.2. I think it's going to be 50 kilograms, but let's double check. Yes. All right. Now, when you have a nice even number, this helps to make things much easier to kind of go along. Again, you don't have to write this in here. I'm just showing you like that's what would go in there if we needed to. If you get a decimal answer for this, and if it's not like to the 10th, I would say save your rounding to the very end. And I'll show you how I would set that up. But since we already know it's 50 kilograms, we'll just work with that. And then I'll show you how we would set this up moving forward. All right. The next thing we need to pay attention to are these questions. So it's asking me two questions. It says, the first question is, what's the number of milliliters to administer for the bolus? Okay, so that's question one. Question two is, what's the infusion rate in milliliters per hour? So I need to know those pieces of information in order to answer the question. We're going to come back to letter C in a moment. So let me open this up. so we can look at and do some calculating here. So I have to bounce around this because I don't have like, I can't just, sorry about that. I can't just like quickly jump up and do all these things. But I'm going to show you how we set this up and how you can set this up using a different weight. And then maybe we might have time to do an extra one with a different weight, just so you can kind of see what that would look like. So it says calculate the number of milliliters to administer for the bolus. So the first thing I need to know and review is, what is the bolus? Well, the bolus is 80 units per kilogram. So we already know our kilogram, right? Remember that was at 50 kilograms. And so I'm just going to multiply by the 80 units per kilogram. When I do that, I'm going to get this number in units. So 50 times 80, I'm going to get 4,000 units. I'm showing this to you initially in steps, and then I'll show you how you should probably set it up and then just do one long calculation. So again, if all they wanted to know was how many units, I'd be done, but it says how many milliliters. So I need to know how to convert units, what I'm going to get rid of, to milliliters. We have two pieces of data that are going to help us out with that. The first piece of available that I have is I have heparin, 25,000 units and 250 milliliters, half normal saline. That's good. That's in my IV. But it also says I have a bolus dosage strength of 1,000 units per milliliter. What am I calculating? It says calculate the number of milliliters to administer for the bolus. So I want to use the bolus dose for this. Now, I always tell the 220, 230 students when they're first seeing this, keep this in mind. When we're talking about a bolus dose, what we're referencing and what we're talking about is um, basically like it's separate from the IV, right? Someone's coming in, you're coming in as the nurse with the syringe. The syringe has a strength of 1,000 units per milliliter, but you're not going to push all 1,000 units into the patient. This is heparin, right? So if you push all 1,000 units, you're probably going to cause them to bleed out. We don't want that, okay? What we want is the appropriate amount, but it's going to get pushed in to the port that's connected to their IV. The IV, the heparin 25,000 units and 250 ml half normal saline, that's what we're going to calculate our infusion rate based off of. So they're getting heparin in both scenarios, but the bolus dose gives us heparin now, like real quick. And then the other heparin basically just drips in. So that's why they call it a heparin drip. And you're going to see why, because I think sometimes your answers are like 10 mil per hour or something really, really trivial and small. But it's a small heparin drip. Okay. All right. So let's go back here. So that was what? That was 1,000 units per milliliter. So before I do any calculation, I'm already in milliliters. So I'm just going to get an answer of 4 ml. So you're going to administer 4 mLs for the bolus dose of this medication. Any questions on how I got to 4 ml? Was that straightforward? Was there something that I missed that you're struggling with, or does that make sense? You don't have to answer if it makes sense. I'm just saying that. In the future, like if you get something like, let's say it's maybe it's not exactly 50 kilograms, like let's say it was like a 113-pound patient, the way you would want to set that up is I would recommend that you set it up like a full dimensional analysis. You're going to hate this, but just so you can kind of see what it looks like as we're kind of progressing through, we're always going to multiply by 80 units per kilogram. And then for the bolus dose, we're always going to be dividing by 1,000. So I know that when I've done this historically, students hate this because it's a whole lot of things. But if you keep in mind, when it's organized, you know that you've set it up right before you do any kind of math, right? So if you are dealing with a question where the patient's weight, like, so if you just plug it in your calculator and it's like, it ends up being like 50.4545 repeating, round at the very end. Don't round at the beginning. Save your rounding to the end. Okay, unless you're told otherwise. But this is most likely the best way to get to your final answer. No matter which way you do it, you should get to the same final answer. And honestly, I don't know if it matters if it's a difference of 4 and 4.1 mil um, when it comes to heparin. I'm not sure what point a tenth of a milliliter, like what kind of impact that makes. But I'm also not the one that makes that determination. The other thing is when you're actually working in a situation where you're actually doing this administration, they may even tell you like, oh, okay, yeah, for this patient, the protocol is 5 mil. They might even just tell you right off the bat. And so you may not even have to do these calculations, but you have to know how to do the calculation for your test. All right. So this would be correctly answering part one of question 25. So the second part is to calculate the infusion rate. So we go back to where it tells us what to start, and we're going to start a drip at 18 units per kilogram per hour. Okay. So remember how we did our calculation for our patient? So we have a 50 kg patient, and we're going to multiply by the 18 units kilogram hour. So what happens is kilograms gets eliminated, and then we get 900 units per hour. So I want to double check. So I'm basing that off of memory. All right, so 50 times 18, 900. Yeah, good. Now, again, I don't want units per hour. I want ml per hour. So I need to have a way to convert units to milliliters. So I'm going to go back to my available, which is step 2 of the protocol. And I have the 25,000 units in 250 ml half normal saline. I also have the bolus dose strength. I am not counting a bolus dose right now. I am calculating an infusion rate. So we use the bolus dose for bolus dosages, and we use this area, we use this when we're doing our infusion. So I'm just going to write that infusion rate. Okay. So we want to use our IV for our infusion rate as our available, just like we did in the like question 22. It's basically the same kind of setup. So we have 25,000 units, 250 ml. So units cancel out. We're left with ml per hour, which is what we're looking for. And this actually ends up being 9 milliliters per hour. Did anyone try this question? Did anyone have like get stuck on this question, or is this kind of you went through my YouTube channels and you already knew how to do it all? Okay. So before I do the second part, let's just do a different version of this. So what I'm going to do is, okay, good. What I'm going to do is I'm going to give you another patient weight, and then I want you to calculate the bolus and then calculate the thing and then just type it into the chat and just make sure we're getting the same answers. So what I want you to do is we're going to do for a 227-pound individual. So the person weighs 227 pounds. I'll leave up all the data points here because honestly it's there, but you should have access to your stuff. I just want to know what would be the bolus for a 227-pound individual? And then what would be the drip rate for this individual? As soon as you have an answer for both, go ahead and type it into the chat. You could put it on in the direct message to me mode if you don't want to share your results with everybody. But if you don't care, then just go ahead and put it into the chat.
I'm sorry, I just have a question.
Yeah, go ahead.
So whenever this is like one of those weights that doesn't like it's an odd number, like
Mhm.
it's 103.18181818. Like how do we do that? Like how do we write it out whenever it's like a number like that?
So what I would recommend is technically to do proper rounding, you don't want to create or you don't want to put your answer or you don't want to round until the very end. And so what I would suggest doing is once you've taken the 227 divided by 2.2 and you have that number, keep it in your calculator. And then what's the next step? So like if you want to write shorthand, like on your notes, you can say, oh, it's 10 whatever point, whatever. Like write it down shorthand, but keep the full, like you said, whatever that number was, keep it in your calculator and then times it by 80, divide it by 1,000.
Okay.
Does that make sense?
Yeah.
Okay. Now I'm starting to see some answers come in. I want to pay attention to what your rounding rules are. So if you have a number greater than 1 mil, where do you round it to? Because so far the answers I got are there's too many there's too many points. So you'd miss those questions because your rounding is off or you didn't round appropriately. There you go. Sorry. So as you're going through, I'm just going to go ahead because I'm getting some feedback and we're running a little bit short on time. Um, what you should get for your bolus, the bolus should be, and I'm seeing this coming in, so good work, everybody. Um, you should get 8.3 milliliters. For your drip rate, it should be 18.6 milliliters per hour. Now, I think that I don't know if you're supposed to round that to 19 or not. Um, I've always been told that if it's mLs, we can round it to nearest tenth. If you have that question, I would definitely ask your instructors about it. But I've seen that in the keys before with that decimal there, so it should be fine. But that's what we should be getting. So, okay, good. No, you're good. Good. And don't forget your labeling. So let me go over this just so you can kind of see what you should be getting with this. And for those of you that are like kind of going through. So first of all, I'm going to show you the shorthand way of how to do these questions. So this is the one that like it gets buried in the YouTube channel. But so what I would do is this is exactly what I type into my calculator. I take 227 divided by 2.2 times 80 divided by 1000, and that equals the bolus in ml. Oop, not bolum, bolus. What I'm showing you is this is the shorthand, okay, for the bolus in milliliters. What did I actually do? I took 227 pounds times the 2.2, that's pounds per kilogram, times the 80 units per kilogram, times the 1000 units, and then 1 milliliter. So anytime like when I have a student like reach out to me and ask me like, oh, I did it for this weight, what do I do? This is what I plug into my calculator. So notice I don't do any, because I knew that's why I gave you the 227. I knew it wouldn't be an even number. And so you should get I think it's like 8.25 something, but you're going to round that to 8.3 milliliters. And I think most of you got that who are working through that. Okay. What you don't want to write is the 8.25 milliliters. You don't want to do that because when you have a number greater than 1 milliliter, you want to round to the 10th place. So make sure you're following your rounding rules. So look at the 5, round up if it's 5 or greater, and then 8.3 milliliters is what you'd want to do. I do basically the same thing for this. For the drip rate, I take the 227, divide by 2.2, multiply by 18, and then I divide by 100. And then that gives me my drip rate. Again, this is the shorthand. I don't expect you to like do all this stuff. This is just because I've done the heparin protocol, like I said, for 10 years, at least twice a year, talking about this with students. And so I have this kind of memorized, but it's a shorthand way because if you ever just want to quickly check your answers, this is a shorthand way to, if you memorize it or while you're practicing, did I do it right? So what did I actually do? 227 pounds. And then I'm going to convert pounds to kilograms. Then I'm going to multiply by the 18 units kilogram per hour. I'm going to multiply by the 250 ml and the 25,000 units. And that's going to give me my milliliter per hour. It's always easiest, right? When I've done it and I'm like, oh yeah, that was so easy. And then don't get confused by when we say drip rate for this or heparin drip rate. Heparin is still in milliliters per hour, and then it'll tell you that it's looking for milliliters per hour. And then what you get is as long as you don't do your rounding ahead of time, you'll get like this is where you'll get the 18.6 milliliters per hour rounded. So round to the nearest tenth. So if you didn't get that, especially the drip question, just keep practicing. If you have a few more minutes, I'll go through the other question, although I will say it's more just for your knowledge. I don't think you're going to get asked that. Um, yeah, if you have it memorized, I don't think they are looking at. So the question was, can you do shorthand all the time for these problems? So from what I understand, they just want to make sure you didn't like copy it from somewhere or just make up the answers. So they just want to make sure that you actually like studied and learned them or know how you're doing it or writing out the thing. So you can. I don't think they care if you write out the dimensional analysis. I think they just want to see that you wrote numbers down on a piece of paper that you didn't just, you know, that someone gave you the answer. They want to make sure it doesn't look like you were cheating.
I have a question.
Go ahead.
Sorry. Every time I'm trying to calculate the infusion rate, I'm not getting 18.6. Like I'm getting 1.85. So I'm not sure like what I'm doing wrong.
Walk me through the numbers you're putting into your calculator.
So for I'm writing it the long way so I can like at least understand it.
Good.
So I'm doing the 227 pounds over 1 times 1 kilogram over 2.2 pounds times 18 units over 1 kilogram per hour, and then times 250 milligrams over 250,000 units.
Oh, your units is too big. It's only 25.
Oh, there we go. That's
Okay.
why. Thank you.
You're welcome. Now, yeah, and then once you do it, you'll get the
Yeah,
18.6,
because it
which
was
is.
one decimal off. So,
Mhm.
okay. Thank you.
You're welcome. No, I'm glad that you like, yeah, that's probably the biggest thing that I see students do is they don't actually make a math mistake. They make they just added one extra zero or forgot an extra zero. So please just pay attention to that. So I'm glad that we worked through that. I had a feel I couldn't think about like I was like, why is it coming out to 1.9? And then I was like, oh yeah, now it makes sense. You were doing 250 instead of 25,000.
Yeah, that makes sense.
All right. So as I mentioned before, you're not likely to see, I don't think you'll see this. I don't even know if fourth semester students will see this. And those of you that are coming in that are fourth semester, I'm just going through the heparin protocol, so it's good for you to see it too, especially since it's been since the spring. So what this next section does, it just says, what happens after they're on this protocol for 6 hours. Well, after 6 hours, they retest their clotting factors and they see that it's the APTT is at 43 seconds. So what we do is we look at remember the whole thing that I circled in red. So I'm going to zoom out again. Try to. The whole thing I boxed in red is the protocol. So we're just referencing the protocol with what we're doing here. So it says we have an APTT of 43 sex. Um, I'm actually still, someone asked if this is 240. I'm still wrapping up with 220, 230, but yes, we're rolling into 240 now as well. So this is also on the 240 test. So it says if it was 43 seconds, right? So what we're going to do is we're going to look at this part of the protocol and we're just going to do what it says. And what does it say? It says to rebolus with 40 units per kilogram. So we're doing a rebolus. Sorry, let me go here. And then it says to increase the rate by 2 units per kilogram per hour. So it's just asking us to do an additional step. So this just comes down to what do we do next? So I'm going to go back to the 110-pound patient because that's probably how this is keyed. So, and then that'll also make the kind of the steps a little bit easier. So again, 50 kilogram patient, but instead of 80 units for the bolus, the new bolus is what? 40 units. And then we're still going to use the bolus dosage strength. So that doesn't change either. So 1,000 units per milliliter. So kilograms are eliminated, units are eliminated, and then this is actually, if you think about it, it's just half. So it would just be 2 ml. So it's just half the bolus. So what you're doing, what this question is asking you is basically to recalculate a new bolus. Okay. So that's what we did. We just calculated the new bolus given the new information. Again, I don't think you're going to have to worry about this. I gave this to you as extra work or extra practice for these questions because I knew this is a challenging question. For the new infusion rate, this gets a little bit tricky. So it said to increase the infusion rate by 2 units per kilogram per hour. What you need to remember is that the original was 18 units per kilogram or 18 units kilogram per hour. So if we're going to increase it by 2, then that makes it 20 units per kilogram per hour. So 50 times 20 times, this is that 250 ml, 25,000 units, because we always use what we have in the IV for our infusion rate. And then we just make sure we cross things out. I'm left with ml per hour. And then I should get, I think this comes out to 10 mil per hour. Right? Because the original was 9. Yeah. And it's an even 10 mil per hour. So I just wanted to show you that that's just another, again, I don't think you're going to see that question on the 220, 230 test. I don't think you're going to see that question on the 240 test, but just wanted to show you that too. So if for those of you that are 220, 230, as we wrap up here, you're welcome to stay on for the 240 review because a lot of it's the same stuff. I just have a couple extra things that that are a little bit different. The 220, 230 review, if you have, or 220, 230 students, if you have additional questions, please email me and I will make sure to reply to that email and answer any additional questions you might have from your packet. So, but thanks for coming on and paying attention, and good luck on your test if I don't hear from you.